So hello students, we are in the final part of our series Force chapter. In today's lecture, we will learn about the center of gravity and about the circular motion of a body. So let's start with center of gravity. What do you mean by center of gravity? Let's assume an irregular object. The object carries multiple molecules. Each molecule has its own weight. Now, what does center of gravity mean? Center of gravity means that it is that point. It is that point. It is that point about which the net MOF of all these weights is 0. So let's me write down. Center of gravity, the short form will be COG, is that point about which the net force, the net MOF due to the weight of the particles is 0. If net weight is 0, that means all the anti-clockwise moment of force should be equals to the clockwise moment of force. Those who don't know what is anti-clockwise moment of force and clockwise moment of force, I would request them to kindly go and visit my previous videos to get a clear concept of what is anti-clockwise moment of force, what are the basic concepts, how are these concepts arrived. So what is center of gravity? It is that point on an object where the total anti-clockwise moment of force, this 3 will be the anti-clockwise moment of force, this 3 or numerous particles on the left hand side of the center, and this right hand side will constitute about the clockwise moment of force. On both sides, the anti-clockwise moment of force and the clockwise moment of force should become equal. That is, the net MOF is 0. That point is considered as the center of gravity. Now, various shapes has various, the center of gravity is located at various positions. For example, a solid cylinder. A solid cylinder can be a hollow cylinder too, solid or hollow cylinder, will have a center of gravity at the center or at the axis. This is the axis. This is the axis. For a sphere, the center of gravity is very simple. It will be at the center. For a sphere, it will be at the center. This is a flat disc. For a disc, again, the center of gravity at center. This is again a solid cylinder. Now we can call this a solid cylinder. Let's write it a solid or a hollow rod. a solid rod or a hollow rod, and this is a solid cylinder, solid or hollow cylinder. Again, the COG is at the center. The COG is at the center. So these are the COG positions at the various shapes: solid rod, circular disc, sphere, and a cylinder. Some other shapes as well. First of all, a cone. Now, let us consider a solid cone. The total height of the cone, let's assume it to be as h. The center of gravity will be at a height of h by 4 from base. H by 4 from base. And if it is asked in question or in your exam that what is the distance of center of gravity from the vertex, then the answer will be 3h by 4 from vertex. So that is for a solid cone. Now let's go to a hollow cone. Again, let's consider the total height to be as h. For a hollow cone, the center of gravity will be h by 3 from base and 2h by 3 from vertex. So you can see that the center of gravity of a hollow cone is a bit higher than the solid cone. For the solid cone, the center of gravity is quite at the bottom at h by 4, and for the hollow cone, the center of gravity is at h by 3 from the base. This is a ring. Circular ring. For ring, the center of gravity is obviously very simple, at the center, but there is one thing you should know. Although it is at the center, but it does not lie inside the body. It is outside the main body of the ring. So this kind of questions can also be asked in exam, that give an example where the center of gravity lies outside the body. The answer will be a ring. It is situated at the center but not inside the body. It is at the middle of the body, which is outside the body. So perfect example for the question in which they will ask, give an example where the COG lies outside the body. The exam is going to be, the answer is going to be a ring. For a triangle, the center of gravity or triangular lamina, you may say, the center of gravity will be at the intersection of the medians. I hope you guys know what median is. I'll just give a short brief description. A median is a line that joins one vertex to the opposite side's midpoint. That is a median. So in this way, we'll have three medians. Let's say we have a triangle ABC. So from A to the midpoint of BC, from B to the midpoint of AC, from C to the midpoint of AB. These three lines are known as the medians. Where these three lines intersect, that will be the center of gravity. And this point has a special name. This point of the center, the intersection of the medians is known as the centroid of the circle. This is known as the centroid of the triangle. Sorry, centroid denoted by capital G. Known as the centroid. The intersection point of the three medians is known as the centroid. Next, you have a parallelogram. It's a simple part. It will be the COG will be at the intersection of the diagonals. So for a parallelogram or a square lamina, it can be a square also, a rectangle also, because a square is a parallelogram, a rectangle is a parallelogram. So any kind of parallelogram shape, the COG or the center of gravity will lie at the intersection of the diagonals. Let's move forward. Now, before I continue into the next topic, a circular motion, I will give you just one more example that there is another shape that is I would say a boomerang. We all have seen a boomerang. Let me draw a shape over here. All these are a part of the circular motion. You all have seen something like this, a boomerang. The center of gravity of the boomerang lies over here. In exam, you may be asked to point out the center of gravity or to draw the center of gravity, the point where the center of gravity lies. All you need to do is, you need to join this point to the opposite middle point, this point to the opposite middle point, and from the top, a straight line. Wherever these three straight lines intersect, that is going to be your center of gravity. This is how you need to draw or find the center of gravity for a boomerang shape. You may be asked this in school, in exam obviously. Okay, so now let's continue with the next topic, that is the circular motion. Now, let us assume that a particle is moving in a circular motion. Let us assume that a particle is moving in a circular motion. The particle is over here. Let's assume the particle to be over here. Sorry. Particle P. Now, the particle P will be initially at that point. Let's assume the rotational motion to be in this direction. Okay, so the particle will change its position like this. Now, when the particle is in the upward direction, the velocity will be like this, tangential to the motion. Tangential to the motion. When the particle will be on the top, the velocity will be tangential like this. When the particle is at the left, velocity like this, and particle at the bottom, velocity like this, and the radius of the circle is said to be taken as r. So when a body is moving in a circular motion, there are certain parameters that remain constant and the certain parameters that change themselves. Now, the first parameter that I am going to discuss is about speed. Speed. Now, speed being a scalar quantity, it remains constant throughout the circular motion. So, speed is constant. Number 2, velocity. Velocity, we all know, is a vector quantity. So, it depends on the direction. Now, at the 4 different points, you can see that the velocity vector is pointing at 4 different directions: top, left, bottom, right. Since the direction of the velocity vector is changing, so Over here in the parameter we will write velocity changes. Point number 3. Kinetic energy. Kinetic energy. Now, energy is a scalar quantity, and we know the formula of kinetic energy is half mv square. We have a very bad misconception, all the students have very bad misconception that this is velocity. No, energy is a scalar. If energy is a scalar, this v should have been speed. Now, normally we take velocity considering that the motion was one dimensional. But it's not obviously necessary that the motion has to be always one dimensional. It can be a multidimensional. So considering that thing, energy being a scalar quantity, this we will consider v to be as speed. Now since speed remains constant throughout in a circular motion, that's why kinetic energy also remains constant. Kinetic energy also remains constant. The fourth parameter, acceleration. Acceleration. Now, acceleration is velocity by time. We all know that. Acceleration is velocity by time. And according to our parameters, velocity is changing. So when velocity is changing, obviously there will be some generation of acceleration. Basic physics. Change in velocity gives us acceleration. So as the velocity changes, acceleration also changes. Clear? So the four parameters are very important to know the circular motion in a proper way. Everyone go through it once. Okay? Now let's move forward. Now, let's take that diagram once again. Now, okay, let's give the direction also, because that is important. The directions are not visible properly. Okay, the directional rotation and the circular motion is complete. Now, when a body is moving in a circular manner, the velocity is changing, and due to the change in velocity, there is a rise in or a change in acceleration. Now, the acceleration such produced always acts towards the center. Let me write it down for you people so that you don't forget. Acceleration produced always acts towards the center. The acceleration produced always acts towards the center. So coming to that point, let me write it down. The acceleration acts towards the center. The acceleration acts towards the center. And since the acceleration is acting towards the center, this acceleration has got a special name known as centripetal acceleration. Centripetal acceleration. We will use the abbreviation A subscript C. Centripetal acceleration. Centripetal means towards the center. Since the acceleration is acting towards the center, so it is centripetal acceleration. The formula for centripetal acceleration is v squared by r, where v is the velocity and r is the radius. And force is m into a. So if we consider the centripetal acceleration, it is going to be m into ac, which is equals to F equals to m v squared by r. Now since the acceleration was centripetal, the force is also now a centripetal. So this force is called a centripetal force. So this force is known as a centripetal force, a force acting towards the center of the motion. Clear? I hope it's clear for all of you. Just go through it once. Okay? Now let's take a few examples of this kind of centripetal forces. For example, here is a nucleus and here is an electron. There is a force acting towards the center, the force of attraction. So here we have the electrostatic force. Which is equals to the centrifugal force. Let's take another thing of the solar system, the sun and the earth. There is a force of attraction, the sun is pulling us. So this is the gravitational force, which is equals to the centripetal force. Let's take another example. Let's say you tie an object, you tie a piece of stone and you rotate it in a circular manner. In this case, the force generated towards the center is known as the tension force, denoted by T, which is actually the centrifugal force, the tension force. Okay, so there are basic examples, daily life examples that can be correlated with the centripetal force. Just go through them once. Okay, so now let's go to the next topic, that is a centrifugal force. What is that? Now, the centrifugal force has been known by many names. Number one, it is known as a pseudo force. Number two, fake force. Number three, imaginary force. These are the name of the same centrifugal force. So why do so many names occur? What is the basic concept of centrifugal force? Okay, for that, let's again take an example of a circular motion. Okay, now let us assume that there are you tie an object and you rotate it in a circular manner. You tie an object and rotate it in a circular manner. Now, towards the center, the force that is acting is your centrifugal force, centripetal force or the tension force, both are same. Now, when I'm rotating something with my hand is fixed. My hand is fixed. This is my hand is fixed. The object is rotating. Right, for that I will feel the tension force in my hand. Something very heavy is moving around. I will feel that force in my hand. That is a centripetal force. And the object keeps on rotating in a uniform circular manner with the same speed. So it is assumed that to keep a body in a balanced position or in a uniform motion position, there has to be some kind of external force acting in the opposite direction. There has to be some kind of external force acting in the opposite direction so that this body can remain in an equilibrium position and continuously cover the path. Otherwise, what would have happened if only this centripetal force would have existed? This body would have come over here with the force. But that never happens. It stays in its path and keeps on rotating. Right? So, although you are feeling a force of something being attached on the other side of the rope, but still it does not come and fall on your hand. Why? Because it is assumed that there is always some kind of opposite force acting to the centrifugal force that is preventing the body from coming down to the center. This imaginary force is known as the centrifugal force. Centrifugal force. This imaginary force is known as the centrifugal force, and hence the word imaginary or the fake, because you don't feel this force, you feel this force. Because this force is counterbalanced with this force. Okay, so that's why it is a fake or a pseudo or an imaginary force. So we can always write that centripetal force is equals to negative sign of centrifugal force. This negative sign signifies opposite direction. This negative sign signifies that both are acting in the opposite direction, centripetal force and centrifugal force. Okay, I hope the centrifugal force is clear. I'll just go through it once more. So centrifugal force is a fake or a pseudo force because it cannot be felt by a body. It is the centripetal force which is felt. Now, it is assumed that to keep an object in an equilibrium or in a steady position, there has to be an opposite force acting or counteracting to the centripetal force. That counteracting force is known as your centrifugal force. And both the forces are equal in magnitude but opposite in direction. I am again repeating, both the forces are equal in magnitude but opposite in direction. Clear? Okay. Now, let's assume, in this case, let's assume that the string that was attached to your hand suddenly breaks, the string suddenly breaks, what will happen? Whatever the direction, tangential direction the particle was, the particle will exit in that direction. The particle will exit in that direction tangentially. The particle will exit tangentially. This is a very important question. If the rope breaks, the particle will exit in a tangential manner to that point. If the particle would have been over here, if the particle was here, then it would have ejected in this tangential manner. Tangential manner. Whatever the point of break is, from that point the particle will exit the motion, circular motion, in its tangential path. Okay, so just see the full diagram on the full board once. So that's all for this in this video. We have completed the full chapter of force. Please do like, share and comment and subscribe to my channel. And if for any doubts, please do comment. I'll try to solve them as early as possible. And yes, please go and visit my previous videos so that you can get a much clearer concept of what the force and the full chapter is. Thank you everyone.